The maximum number of electrons accommodated in 5f orbitals. 5f orbitals. One orbital, if they are mentioning, that will be always 2 beta. But he mentioned 5f orbitals, so each f orbital will contain 2 electrons and 7 f orbitals will be there, so 7 to the 14. The maximum probability of finding an electron in a particular energy of an orbital is about 95%. It is the definition. The three-dimensional space around the nucleus where the probability of finding electron is 95% is known as orbital. Number of nodal spaces in 4s orbital is 3. Okay, number of nodal spaces in 4s orbital. Okay, now if you take like this 1, 2, 3 and 4. 1, 2, 3. 3 nodal spaces. The p orbital has a dumbbell shape, correct? Electron present in p orbital can have any one of the 3 values of magnetic quantum number. Of course, correct, but there is no relation between them. Both statements are right statements. The number of nodal planes for a px orbital is, for px orbital, yz is the nodal plane. So there will be one nodal plane. Number of nodes in 3p orbital. For every p orbital, there will be one node. For 3p orbital, sorry. This is for 2p orbital and this is for 3p orbital. And this is the nodes. For every p orbital, there is one nodal plane. For 2p orbitals, no nodes. For 3p orbital, this is the one node. And then coming to the 119th question. The orbital without nodal planes is obviously 1s orbital because it is very close to the nucleus. No space, like electron is not present. Okay, no, that is not possible for 1s orbital. It is immediately present around the nucleus. The number of spherical nodes in a 4s orbital. Same thing. 4s orbital means just now we were taking this question. 1, 2, 3, 4. 1, 2, 3. 4s orbital. If it is 3s orbital 2, 2s orbital 1, 1s orbital 0. Which orbital has its 4 lobes along the axis? dx square minus y square orbitals will be like this. dxy orbitals will be like this. dz square orbital baby sutar shape. dxz, dy both are will be the same. So answer is option 2. The density of electron cloud of the orbital dxy in yz plane is, for dxy orbital, yz and xz are nodal planes, means there 0 probability. Nodal planes. The probability of finding an electron in py orbital along the x-axis. Obviously, see, py orbital means if this is the y-axis, it is the x-axis, the orbital is present here, py orbital, and along the x-axis it must be 0, it must be 0, it must be 0, it is 0. The number of nodes and nodal planes in 4p orbital are respectively, just now we were discussing 4p orbital, where it will start. 2p, this is for 2p, this is for 3p, this is for 4p. 1 and 2. 2 nodes are there, number of nodes will be 2. For any p orbital, number of nodal planes are 1. For any p orbital, number of nodal planes are 1. So this is your answer. For px orbital, yz, for py orbital, xz, like that. The number of nodes possible in radial probability distribution curve of 3d orbital. 3d orbital is the first d orbital. 2d is not there, but 3d orbital. 3d orbital will be like this when you are taking d versus r graph. So 0. The number of nodal planes d orbital has. For every d orbital, we say 2 nodal planes. For example, dxy orbital, yz, xz are nodal planes. In the radial probability distribution curve for the 2s orbital of the hydrogen atom, the minor maximum, the node, and the major maximum occur at the following distances from the nucleus respectively. See, for 2s orbital means it will be like this. This is for 2s orbital when you are taking d versus r graph. Radial probability distribution curve, d function versus r, where d is 4 pi r square dr psi square. So he is asking first minor maximum, then major maximum. Minor maximum is at 0.53 angstroms. Major maximum will be at 2.6 angstroms. And this distance will be 1.1 angstrom. So option 2. 128. There are two nodal regions in 3s orbital. There is no nodal plane in 3s orbital. सही है ना? Well said. 1s orbital, 2s orbital, 3s orbital. This is node, this is node. So two nodal regions is right statement. For s orbitals, there are no nodal planes, right statement. But what is the relation? There is no correct explanation. 129. We'll stop here after this question. We'll continue in next video. Bohr's atomic model. Okay, all these options we need to check. De Broglie's concept, Sommerfeld atomic model, Schrodinger's wave equation. What are the options given here? Bohr's model is quantization of angular momentum, right? Sommerfeld atomic model is about atomic model. Schrodinger's wave equation, de Broglie's concept is dual nature. Schrodinger's wave equation is fine spectrum. All these you can take like this. We'll go with the option. Question number 129, where the options are, we'll take little bigger. Yes, from here to there we'll see. And for A, it is quantization. Correct. For B, it is dual nature. For C, it is atomic model. For Schrodinger wave equation, it is fine spectrum. Done.